Hi everyone, and welcome to this SolidWorks 22-minute Model Mania 2019 webinar. My name is Allison Savell, and I'll be your host for today. Let's jump right in and get started. We have a lot to cover in 22 minutes. Just a couple of quick items I wanted to point out before we get started. First, in using GoToWebinar, please notice the full screen button to move in and out of the full screen mode. We suggest using full screen mode. If you have any questions during the presentation, please enter them into the question section, not the chat section. We'll be answering them at the end of the presentation. Also, we have a few poll questions during the presentation today to keep things a bit interactive. We ask that you answer them quickly, and we'll move to keep within the time frame. Please note that we will be recording this session, so it'll be available after the presentation and the follow-up. So let's get started with the first poll question. Have you been to SolidWorks World before? Yes, you've been to one event, you've been to more than one event, or no, you've never attended, but you want to. Let's give it a couple of seconds and see where we are. All right, close that, share that with everybody. So wow, almost 80% of you haven't. Well, this is a good introduction then. So with that, why don't I introduce you to our rockstar presenter today? With us, we have Mark Schneider, who is a senior SolidWorks solution consultant. He's responsible for many of the demo videos you might see, and our Model Mania guru. Mark, it's all you.
Great, thanks, Allison. So as Allison had asked in her question before about SolidWorks World is our international user conference that we hold every year, usually in the February timeframe, where all the users get together, learn new things, network, and it's a really a good time, a great place. But one of the things we do at SolidWorks World is we hold a little contest. We call it Model Mania. And we've done this for the last 20 years now, and you can see these are some of the parts that we've done over the past 20 years. Complexity. It's a timed contest. Accuracy is considered first, then we judge based on time. So for this year, so these are the past year's models that we've asked people to sit down and do. For this year, here's the part that we have. So what happens when you sit down to take the Model Mania challenge is that we give you a drawing and we ask you to model a part. Then when you're done modeling that part, we'll give you another drawing, which we'll call phase 2. We'll show that in a second after I model this up. And in phase 2, we ask you to make changes to the same part and run a quick simulation. So you can use SolidWorks Simulation or Simulation Express. All we're asking for is what is the factor of safety. So very simple simulation just to make sure everybody can get through one. So this is our phase 1 part for SolidWorks or Model Mania 2019. Looks like a fairly simple part, nothing too crazy here. If we look at where I'm going to start is down here. So when I look at this drawing, I'm looking at this view down here, and I'm going to say I'm going to sketch out this shape here, 10 millimeter through dimension, 8 millimeter radius. That's a diameter. That's a radius. That's a radius there. I'm going to include that all in one sketch. It's going to be 70 millimeters long by 24 millimeters tall, and then we'll come back and put this pocket in here, which is 50 millimeters, and that's a cylindrical face that is created right here. We can see. Finish it off by putting in a counterbore hole down here. Actually, early on, we'll add this draft here because I always like to draft early and fill it late. We'll add this counterbore down here, and we'll do that using the hole wizard. So I would encourage people, if you're not familiar with the hole wizard, it saves you. It's just a tremendous time saver. M6 socket button socket head cap screw is the size that we'll put, and that's all we got to do is identify the screw, and SolidWorks will take care of all the sizes. So that's centered down the middle. What else we got? Two millimeter fillets that go all around, and those are all highlighted in red there. So let's go ahead and get started with this and kind of jump right in. So the first thing I'm going to do is I'm going to start on that right plane and go ahead and start sketching. And one of the things you'll see when I go through the presentation, you'll see this wheel that pops up, and I always like to make sure that people understand what this is. These are mouse gestures. Another thing you'll see pop up is this little toolbar. Pops up in part mode, assembly mode, drawing mode, sketch mode, whichever, and they can be customized for any of those. And I do that just by hitting the S key. That's called the shortcut bar. How do we get to these things? We go to customize. Here's your mouse gestures. So each of these can be customized, so you can add which items you might want to use over and over again. I use them both. So some people don't use any, some people use one or the other. You get to choose, customize it to the way it works for you. So here's the shortcut bar. These are, again, customized with any toolbar buttons that you want to put on there. Things that you use often, I would encourage you to customize those individually. So you'll see that pop up as I go. So I'm going to draw a center line in here, and I'm going to draw this center line over to the left, and I'm going to make it 22. So you can see that I'm doing numerical input when I'm sketching. Again, another question that pops up a lot in demos: where does that come from? How do I turn that on? If I just right-click in the graphics area, you have this little button here. It's called Sketch Numeric Input. Go ahead and turn that on. Another setting that I would encourage you to take a look at are these two buttons right here. So just hit the help down here and look for these two right here. And it'll explain what happens when you have that on, but it all takes account for when I'm doing the sketch numeric input. So let's get that stuff out of the way here. So I have a horizontal construction line on there, and then I'm going to draw some circles. So this one's going to be 10, this one's going to be 16, a radius of 8, and this one I'm going to make 30, which is a radius of 15. Now, it's not necessary to do this, but what you could do is take some of these and say, these two, I want them to show up as radius dimensions. So you can do that if you like. It's certainly not necessary. It might just help you when you're studying the drawing. 10, 15, 8, everything looks like it did in the drawing. So now I'm going to add some lines. So I'm just going to pick up the tangency while I'm sketching right here. You can see the tangency has been captured. I'm going to come over just north of my origin, drop that line there, come down here, and we'll pick up tangency right there as well. So now I have that tangency established. I'm going to crossing window select these three items right here. We'll make them symmetric. You can see now my model behaves kind of as I expected. And the height of that was 24. And there we have our first sketch. Now, one of the things you'll notice is I included a lot of stuff in this one sketch, and I'm not going to trim it up. This is called using contours. I have the shaded contours turned on. I like to use contours. I don't want to waste time trimming things up, and then I might have to make a change down the road, and I got to untrim something or redraw something. Just leave them as it is, and then work with the contour. So it's one thing that I tend to use quite a bit. So I'm going to extrude this, and you can see that it doesn't know what to extrude, but I can choose the contour. So I'm just going to choose this, and this. Drag this out. I want this to be about the mid plane, and I want it to be 70 millimeters. So we'll make that 70 millimeters, and I'll accept that. So there's our first piece of our puzzle done there. And I'm going to take this sketch and reuse it, and I'm going to create a cut using that same sketch. Again, here it doesn't know what I'm going to do. So if I grab this contour right here, notice that you get this Pac-Man looking thing, because what happened is I grabbed just this contour, just this region, and I can tell that by when it says sketch region down here in my contours. I'm going to clear that and choose just the circle. What that does is it chooses the entire contour. I want to make this midplane 50, and we'll go ahead and accept that as my cut. So I cut that material away, and everything just using the same sketch. Little hand underneath there means that it's a shared sketch. It's used more than one time. So next thing I want to do, as I mentioned earlier, I like to draft early. So come back to our drawing. We'll add this 5 degrees of draft. It originates back here at this face, so we'll use that as our neutral plane. Front plane here, it's the same one there, and I will add the draft. And let's make this 5. And the faces to draft are going to be this one and this one. Always make sure you check the direction of pull. So you make sure you know which way. That's the way the mold would pull if you're adding the draft. So my direction of pull is correct, and I'll go ahead and do that. And that slopes those faces down there just nicely. Okay. Now what we want to do is, so we have this part done, we've got all this captured. All we got to do is this and our fillets. So let's go ahead and do that. So the whole wizard. When I grade all these parts at SolidWorks, well, we have probably 240, I think, people sat for Model Mania this year. When I grade all these parts, I notice maybe only 60% use the whole wizard. I would encourage people to learn to use this. You got all your different hole types that are available here. I'm going to choose the counter bore. You have all your different standards that are available here. You also have all your different screw types. So this is a socket button head cap screw, M6. It's going to be through all. And then we define the positions. So here's where you, or what SolidWorks allows you to do, the hole wizard allows you to do, is apply a hole to either a planar face or to a non-planar face, in this case, a curved face here. So I'm just going to go ahead and choose that face. You can see what it's doing is it's put me in this mode where I'm placing a point or placing my hole. So I'm just going to place it right on there. One of the things you'll notice with this point is it has an on-surface relation. It knows that that is on surface. Another thing is when I'm placing it on when I'm creating a hole wizard hole on a non-planar face, it takes me into 3D Sketch as opposed to 2D Sketch. So I would encourage you to play around with 3D Sketch and understand how to work with that. So if I look down here at my Z direction, I want the origin and this point to be along Z. I want the point to be along the same Z as the origin. So what that does is it moves it into position, makes it black, fully defined, and that is now fully defined and ready to go, and there's my hole. And again, all the information for that hole is already defined. I didn't have to key in, I didn't have to look it up, I didn't have to get Machinery's Handbook out or my slide chart or any of that kind of stuff. We already know all that stuff. The hole wizard knows that. Finally, what we'll do is we will add some fillets. These are going to be 2 millimeters. And I'm going to choose these edges here and also this face here. So just grab those 3 faces and add that. This isn't necessary, but one of the things I like to do is just apply an appearance to that feature. And what that does is just helps me visually understand and see, you know, that particular fillet and make sure it captured all the edges that we have. So that's it for phase 1, with the exception of adding material. So on the drawing, we define the material. So we got to do everything that's on the drawing. So define the material. And here's a pro tip for anybody out there. So on your favorites, you will always find the material that we specify in Model Mania. I always set that up that way. So you'll have plain carbon steel on your right click there. So that's just going to be plain carbon steel, pretty simple there. And the last thing we ask for is what is the mass properties. 131.14 grams is the mass property for this particular part here. So that's phase 1. Once you're done with phase 2, what we'll do is we'll give you another sheet and we'll say, okay, now you got to make changes to this same part. So here's phase 2. So let's start down here and take a look at what we want to do. Make the changes as indicated by the red revision clouds. All the other dimensions stay the same. And then do the simulation that's defined over here. So let's start down here. And the first thing we have is we now, instead of having 1 counterbore hole, we have 2. And those are spaced. We do the math here real quick. You can see those are equally spaced, 30 millimeters about the center. We'll remember that. And we have these 2 arcs on the side here of 30 millimeters that we're removing material. We're actually removing material because it's 70. 70 is, we're still maintaining that overall width of 70 millimeters. Let's take a look at what we're doing up here in this view here. So we're adding draft to the inside faces, 8 degrees of draft, but we want to maintain 50 millimeters center a hole to center a hole. So we're going to need to figure out how to approach that one. Fillets all remain the same. No dimensions over here change. And then when it comes time to do simulation, we'll hold this face, apply a fixity there, and then apply a vertical load in this direction to these 2 green faces of 100 newtons each, total of 200 newtons. So let's figure out how we're going to approach this over here. So first thing I want to do is I want to cut those arcs on the side there. So I'm going to roll back in time. We'll go all the way back here. And on this back face here, I'm going to create a sketch, and I'm going to create a center point rectangle. I have the from midpoints as opposed to from corners because that gives me vertical and horizontal center lines that I can use for mirroring. This guy, and this guy, not the face, I'm going to make those construction geometry because I want to sketch in a 3-point arc. Goes from here to here. We'll make this tangent, add a dimension, 30, and then I'm going to take this arc, mirror it about this center line, mirror that to the other side. You can see what our contour looks like. Now, I don't want to cut the inside away. What I want to do is I want to cut away the outside. So in order to do that, I'm going to hit this little button here called flip side to cut. I get this little arrow comes on here. It shows me which direction I'm cutting away. So I'm going to cut away the material on the outside there. So that gives me those 2 arcs on either side of my model, which is exactly what I'm looking for. All right, this feature, no problem, as expected. Okay, what about the draft? The draft fails. Well, it lost those faces because we cut them away. So let's just go into the draft command and reapply it to this face and to this face, and I'll hit OK. SolidWorks tells me, hey, there's missing entities, these two faces. SolidWorks will remove them automatically for me, so it goes ahead and takes those off. So we look at a top view, there's our 5 degrees of draft. We have our arcs on the backside, and we're ready to go with the other change. So we'll work up here. So we want to maintain that 50 millimeters and then 8 and 8 on these two inside faces. So let's figure out how we're going to approach that. So I'm going to do this the wrong way here first. I'm going to grab this face here, and I'm going to before I do that, let me just add the draft. So we want to add that 8 degrees of draft. So where do I want to draft about? We can try the front plane here. And if I do that and I want to draft this face and this face, 8 degrees, my draft direction of pull is correct. That looks good. But watch when I draft this. It drafted it because it took that plane, projected it all the way back to that front plane and drafted the whole face. It moved it too far. I no longer have 50 millimeters center to center. So how do we fix this? I'm actually just going to roll back before that, show you an easy way to do that. I'm going to take the front plane here, and I'm just going to control drag it out here. And I want to define the second reference as a temporary axis, which is right here. But I don't want it to be perpendicular. I want it to be parallel to the front plane. So define that second or that axis. So this axis, or this plane that I've defined here, goes right through the center of my model, right through the center of my holes, I should say. So now that plane, obviously before this draft, now what I'm going to do is when I apply this draft, instead of using the front plane, I'm going to use this plane I created here. And I want you to watch what happens when I do this. You'll see, and back here I'm going to add material, and back here I'm going to remove material. So if I roll that back, roll that forward, you can see what I'm doing. I'm pivoting about that plane that I created there. So again, draft can add material and remove material, so it's very powerful that way. We'll go ahead and hide that. We'll turn off our temporary axes for now. And then, okay, so that draft is done. Let's see, what do we got to do next? We got to do our fillets. Well, look at our fillets. Our fillets are just magically ran all the way around there because I chose faces. In this case here, I still chose that edge, and SolidWorks was smart enough to remember that. So the last thing we need to do is we need to change this, add a second hole here. So I'm going to edit feature, and we'll go into positions. And here's kind of an exercise in how to use the 3D sketch. So I'm just going to come in here and place yet another hole onto another point onto that face. You can see that that point has an on-surface relation. This one had that along Z that we created before. So I'm going to delete that, and I'm just going to move this guy over here. It's still on surface, but it's no longer tied to that location. I'm kind of a big fan of using construction geometry, so I'm just going to draw a center line in there. I want to make this along X. So that is that constraint is along X for that line. Add one more construction geometry from the origin to the midpoint, and this one is going to be along Z. And now all I need to do is add a dimension. All I need to do is add a dimension between here and here. That's 30. Because it's centered, my sketch becomes fully constrained, and I'm good to go. So that's how you would define, one way to define those holes without having to create revolves or do whatever else. Next thing we will ask you to do is we ask you to do a simulation. So you can use SolidWorks simulation or Simulation Express. All we ask for is what is the factor of safety. So either one of those will work and give you a factor of safety. So I'm going to use SolidWorks simulation. Create a new study. Just a static study is fine. We're going to hold this part by adding fixed geometry to that back face as we defined it. And then we'll apply a load to these two faces right here and here, and those are going to be a force. Just apply a force. It's going to be not a normal force. It's going to be in a selected direction, and I want the direction to be normal to the top plane. So I'll choose the top plane as my direction. Normal 1,000 per item. So we get a total of 2,000. And I have my load on there. I have everything good. I hit run. Second or two comes back and we have our stress results. I always like to animate this. It helps me understand, yeah, is this behaving as I would expect it? In this case, the answer is yes. And then last thing we ask for is what is the factor of safety? In this case, 3.9. So that's Model Mania for 2019. Now, I know we're right about at the time limit. If anybody wants to stick around, I have another couple minutes. I'll show you some other techniques and methods that people use to add this draft here or these curves here. So if you want to stick around, give me another 5 minutes and I'll do that. So let's take a look at how that would, how someone would approach that. So I have this one that's done at phase 1. It's a pre-saved model. So this one here is what we had at phase 1. So I saw some people that were approaching this a little differently than the way I did, which is, the flip side to cut and whatnot. They actually extruded an arc shape out here at an angle. So they extruded in that at an angle. How do you do that? So on the top plane, I'm going to create a sketch, and I'm just going to draw a line from right here to here. We'll add a dimension of 5 degrees, and I'm just going to exit out of that sketch. So that sketch is done. It's basically just a sketch at 5 degrees. On the back face here, I will create a sketch, and I'll put a 3-point arc in from here to here, out to there. We'll make our tangency and add our dimension. And then I'm going to take this and this, we'll make those vertical to each other. So my sketch becomes fully constrained, looks good. And then I'm going to create a cut. So I'm going to cut using that sketch right there. And I'm going to make this a thin feature. We'll make it like, I don't know, 10. I'm going to flip the direction of my thin material. I'm going to make sure that that goes all the way out or through all. And instead of just cutting that normal to the sketch plane, I can use this option right here, which is the direction of my cut. So I'm going to choose that sketch I created. So you see how it tipped and it rotated over at that 5 degrees. So that's the direction in which I'm actually extruding this feature. A lot of people are familiar with that capability. Some are, some aren't. Jump to a top view here. You can see that matches that line quite nicely. I won't go through and do the other side. If you were going to do this, you'd have to do the other side or cut your part in half, mirror it over, however you want to do that. The draft isn't needed anymore because I've edited it, kind of included it inside of this feature. Now, someone could argue and say, well, if you extrude a circular item and then cylindrical item and then add draft, it's going to be conical, and that's true. This isn't conical. This is more of an elliptical shape that happens to have a planar cross section through it that is circular at some point. So it's a little bit different, but it matches the drawing. So the drawing is still 5 degrees. Everything is still identified quite right on the drawing, so it can't take off for that. So a couple other techniques for creating this. One way is to go in and use move face. So I could do move face here and just use the rotate option and just try to rotate this face out like this, but I want to rotate that specifically about that origin. Now I could try to tweak some of these numbers here and say, okay, the Z direction needs to be 22, and you could do it that way. Probably a little bit better approach to doing that is to sketch on this face here and then draw in a line from here up. So this is going to be the axis that I move and rotate that face about. So we'll do it again, move face. I'm going to choose for direction, I'm going to choose this line that I created. So this is the axis at which I want to rotate about, and this is going to be 8 degrees of rotation. Make sure I'm going in the right direction. I am not. We'll flip the direction of that, and that rotates that face out. I still get the same thing. The center of that circle is still in the same spot. You have to do it to the other side as well. So I'll do one more way in which some people approach this as well, which is just as valid. So on the top plane, I'm going to draw in a construction line, horizontal construction line from one side to another. We'll turn our temporary axes back on, and I want to make my construction line and that axis collinear with each other. And then, so now I have that line that's in there. I'll add a dimension just for grins here. And that's 50. That's kind of what we want. That's that number that we want. And if I jump back to a top view here, I will draw in 2 more lines. So a line goes up here. And let's actually just do a center line here like this. And we'll make these 2, we'll just mirror that to the other side. So I have 2 lines there. We'll add in a angle of 8 degrees. That's at 8 degrees. And then we'll extrude this as a surface. So I'm going to extrude that as a surface. Doesn't matter how tall this is, how big it is. I'm just going to make a surface, 2 surfaces that I do that. So I have these 2 surfaces in there at that 8 degrees like I have. And what I want to do is I want to use the replace face function. So replace this face with this face. And that you can see it rotates that over there. So that being defined at the center of that circle, it's able to rotate that face. So those are 2 other techniques that people had used to create the same thing. Obviously, in this case here, you'd have to do the same thing on the other side. I think adding the draft, creating the offset plane out here, adding the draft is even better. There were even a couple people who, when they created their model, they created their front plane was down the center of, they just luckily chose that the front plane was down the center. So you already had a plane that was defined there. You didn't have to create that extra plane for the draft. So that's Model Mania 2019. And I encourage everyone to come to SolidWorks World next year and give it a try. So I'm going to turn it back over to Allison for another couple of poll questions. And then from there, I will answer questions afterwards.
All right, thanks, Mark. So we have 2 left. I'll launch this one. So give you a couple of seconds to answer it. What's your level of interest? If you're just checking it out, seeing what's new, looking at other products. Obviously, we do more than just SolidWorks core. And you saw simulation, so let us know. Give that a second. All right, I'm going to close that out. And then our last one, would you guys like any further information from us? So if not, that's great too, but let us know. We'll definitely follow up. I'll give that a second. And then Mark will hit you with some questions or answer your questions. All right, I'll close that out. And Mark, I'll go back to you.
So these are our winners. I always like to give a shout out to the winners. Our customers compete against customers, resellers compete against resellers, although we may change that up like next year and let everybody compete in the same category. But you can see some of the times: 12:07, 11:20 for the times to complete the model. Got some real hot shots out there, and frankly, a lot of these folks will take some time to study past Model Mania parts. And one of the questions that came up was, are there downloadable documents? So every one of these for the last 20 years are available on mysolidworks.com. So go to mysolidworks.com. In the search box there, just type in Model Mania, and then it'll take you to this page here. If you click this tick for blogs here, the first one that pops up will be this 19 years of Model Mania. Actually, starting early next week, we'll post the drawings for this year for Model Mania 2019, and the recording of this webinar will be posted there. So for every one of the years, we have the phase 1, in the early days, we didn't always have phase 1 and phase 2. There were a couple different, some of them didn't have simulation. But what will be posted there is 20 years of Model Mania and all the drawings that you can do and play around with them, and also the solution videos as well. So, and the whole goal of this thing really is a learning experience. Hopefully somebody is able to pick up a tip or 2 that can help them be more productive. And that's all I got, Allison.
All right, so that answers, we touched on all the questions as well. Yep. So awesome, thanks everybody. And like I said, this has been recorded, so the follow-up will be in the follow-up email you should get tomorrow. And thanks for joining, and have a great day. Bye.